So, welcome to the post lunch session of day 5. So, we will be starting this tutorial number 7. So, it is estimation of drying kinetics and energy consumption of agricultural products. That is one problem, and maybe another problem we will solve. So, problem goes something like this. You can consider total mass of grapes is about 100 kg, and the initial moisture content is 75 percentage, and final moisture content is 14 percentage, and drying time is 2.8 hours, and maximum allowed temperature is 70 degrees Celsius, and ambient temperature is about 25 degrees Celsius. Okay. So, how to proceed to this problem? So, what are the parameters? T, Mi, Mf is known to you, and then you have maximum allowed temperature and ambient temperature is known to us. Then what could be the water removal based on the wet material moisture content. So, we can find out W in minus W out divided by 100 minus W out. Okay. And then if you substitute these values, then it is it should be moisture content is like 74 we have considered, but it is it should be 74 actually. And then it will be this is 74. Then your W will be 0.71 kg per kg of material, right. Then for 100 kg of product, water that has to be removed is how much? This is 0.71 kg per kg of material for 100 kgs. You multiply with 100, then it will be 71 kg, right. And the amount of material dry in 2.8 hours. So, it will be like 100 kgs, and time is 2.8 hours, right. So, it will be 35.71 kg per hour, right. So, how to find out this drying rate? Yeah, see, drying rate you can find out by using this 35.7, okay, 71, and then you have 0.71 is the kg. So, it will be 25.35 kg per hour, right. So, we need to use a enthalpy humidity diagram. So, it's a long you need to find out what could be the relative humidity at this condition. So, that chart is available, you can just browse it. For your convenience, I have given these values here. So, for air at 25 degrees C and relative humidity 60%, absolute humidity is 12 gram per kg, and enthalpy is 56 kilojoule per kg. Okay. And for air at 70 degree, relative humidity is about 6.5 percentage, and enthalpy is about 100 kg per kilojoule per kg. Okay. So, we can get a average humidity is about 78.5, and for mean air humidity, which is 78.5 percentage, the air humidity at the exit of the dryer is about 28 gram per kg. Okay. and from that chart actually we can find out the corresponding temperature is 35. So, there is a chart. So, we can use that chart with this condition and we can find out what is the temperature at the exit of the dryer. Okay. So, then we need to find out the air needed for drying of 100 kg of raw material. How much air is required for drying of 100 kg of raw material. So, we know m w and then density of air and then x m minus x a. So, how did you get this 28 minus 12? Can someone tell me from where we got these values? 28 minus 12. What is x m and what is x a? Yes. So, this is 28 gram per kg. This is humidity. Sorry. So, exit of the dryer, how much is the dryness, right? And here we have 12 kg. This is absolute humidity. Okay. So, that is 28 minus 12, and from there you can find out what is the air flow. And once you know this, then you can find out the heat needed to increase the drying air temperature from 25 to 70 degree Celsius. Okay. So, for this we need this enthalpies. So, already you know how this can be studied from a psychometric chart, what you have studied in the last class also, because we need to use the psychometric chart. From there we can find out. I have the chart, but I am just cutting short because already you are aware how to calculate it. Okay. So, what really we need about the Q value, which is the heat needed to increase drying air temperature from 25 to 70 degree Celsius. Okay. So, once you know enthalpies and already you know density of air, and then you can find out the amount of energy required. So, these two are at the two different enthalpies, because the enthalpies are functions of temperature, right. Then for about, if we say 2.8 hours of drying period, how much energy consumption would be? So, that can be very easily calculated. So, this is for 1 hour, this is for 2.8 hours, or maybe if we extend for 3 hours, that is also possible, 4 hours is also possible, right. So, next maybe what we can calculate is energy consumption is about 19.52, and then this collector area required may be calculated from the heat required over amount, which is 19.52 for that temperature range, by taking into consideration the solar collector efficiency and corresponding heat losses. Okay. So, once you are confirmed that this much of heat is required, then you can actually do the back calculation. So, if this is the amount of energy you require QU, then you see the amount of losses will take place. Okay. So, that way you can do the back calculation, and then you can suggest what could be the total energy required. That means, this plus UL will be the amount of energy received by the collector, right. So, if you add the losses with this value what you have calculated, right. So, that is how we can do the calculation. So, for this we need this enthalpy chart as well as psychometric chart. So, already you know the psychometric chart, right. At different conditions you can find out, once you know the drying from say this temperature to maybe 45 degree degree temperature, then what is the specific humidity? It is 28 and 14. Okay. So, this is the humidity range. So, you can use this chart and you can find out the enthalpies. These are the enthalpies, right. So, you can find out the enthalpies, and once you know these enthalpies, then you can find out the heat required, right. So, these charts are used in extensive. I think you have used this chart for while doing this psychrometric analysis, but see, this chart can be used in many applications, right. So, yesterday we saw one applications, and today also we saw one applications of using this chart for heat requirement for carrying out a task. Okay. So, temperature sense is known, relative humidity is known, and enthalpies are known. So, from that you can find out the change in what is called heat required for doing that particular task. Done? It's fine. So, now let us solve this problem. Let us spend some more time in this figure. Okay. So, here this temperature rise delta T of air through a vertical south facing unglazed transferred collector. Okay. So, this is no collector, and then as you have seen in the class of Professor Christophe. So, this is goes, and maybe this kind of fans are there, and then there will be ducts here, and then there will be ducts here, and something like this. Okay. So, this is the wall, okay, and air goes something like this. So, what it says, and it is south facing, it is south facing, okay, and this is unglazed transfer collector, no glazing is there, right. And this actually the kind of collector satisfies this expression delta T is 0.03 IT plus 3.0. Okay. So, for an airflow rate of 36 cubic meter per hour per meter square of UTC, that means mass flow rate per meter square. Okay. And IT for solar radiation is given to you is how much? Is the global radiation is given, and then diffuse radiation is given, and you need to find out the total radiation on the UTC, and also we need to find out the efficiency of the system by using this data. Location is given to you, then that hour angle airflow is given to you, then global solar radiation and diffuse radiations are given to you, and of course, relative humidity reflectivity of the surrounding surfaces is 0.2. Normally, we consider 0.2 in most of the calculations. Okay. So, can you start it? Can you start? So, this is Ig and this is your Id, okay, and this reflectivity is rho. Rho is given to you as 0.2, okay, fine. Then the expression for IT, and from this value we can also find out what is beam radiation falling on the collector system. It is Ig minus Id. So, Ig is 543 minus 144. Okay. So, you can find out what is this value. Can someone tell me? 199. It will be 399. Yeah. this is in watt per meter square. Okay. And probably I need to find out this IT is IB, RB, ID, RD, okay. So what is RB, what is RD, what is RR, this also no expressed. Okay. So what is RR is still factor, right? So this is RB is cos theta by cos of theta z. Okay. So what is cos theta? Any beta is given here. Beta is of course 90 degree here. It is 90 degrees vertical. Okay. So beta is 90 degree. Okay. So what is the expression? Sin delta sin of phi, beta is also there somewhere. No, here you have beta will also be there, right? Here tell me what is this value, sin delta, sin phi, then plus cos of phi, cos of delta, cos of omega. Then it is phi minus cos of phi minus beta, cos of delta, cos of omega. You remember this? So now for this unit delta and phi, beta is 90 degree is known. How to find out delta? 23.45 sin of 360 by 365 284 plus n. So now n is for December 10. So you can find out what is n. So n will be, so 365 minus 21 also you can do, or you can add also. Okay. So for your understanding what you should do, so it is like 31, 28, then 31, January, February, March, then April, May, June, July, August, September, October, November, then 10. Add this and calculate what n you will get. Otherwise, what you do, 365 minus 21 is also possible. Then can you tell me what is phi? Phi? Oh. And already you know what happens in equinox days and solstice. So that will give you information. So what could be the values of delta? So, you do not have to do so precise calculation actually, no, sometimes you can find out. What is delta? Zero 4, right? 0.49. Okay. So, now what is phi? Phi is from here you can find out, then phi will be 28 plus 35 by 60. What is this value? Phi is at 28.583. So, latitude is known, then tilt angle is known, then delta is known, beta is known. We can find out what is RB. We can find out what is RB. RB you can find out. Because first we need to find out this total radiation incident on UTC. So, that means IT you need to find out. Can someone tell me what is RB? RB, how much you got? Do the calculation, then you know you will get it. I think you should get something like in my calculations I got it about 1.295. You can cross verify. Okay. Got it. So, what is you have R d 1 plus cos of beta is view vector with respect to the sky, right, and R d will be something like rho is the reflectivity, then 1 minus cos of beta by 2. Okay. So, what are the values of R b, R d and R r? This is the v vector with respect to the ground. Okay. So, for reflected surfaces like when your place is covered by snows, then this point will be very crucial. Okay. Point 5 and here 1 because cos beta is what is 0, right? It's 0.1, it is 0.2, it is 0.1, right? Okay. So, now you substitute these values here in IT and then you see what is the value you get. So, I will just rub this part. Now, these are not required, already you have used those values. Yeah. So, IB is 399, right? 1.295 plus ID is how much? Diffuse is 144, right? 144, then we have RD, this is RR, right? RD is 0.5 and then this is nothing but IG and this IG is 543 multiplied by 0.1. So, now you can tell me what is this value. Okay. So, these are not required now. What is IT now? 641. So, we have done with this total radiation incident on the UTC is 641 watt per meter square. Okay. So, beam radiation is 399, then diffuse is 144 and hence global is 543, but no, actually total radiation falling on the collector is 641 watt per meter square. Okay. So, it is higher, right. So, now what you need to calculate? Efficiency of the collector. So, how do we calculate this efficiency? Efficiency of the collector. So, how are you calculating this efficiency? What values are given to you? Useful heat gain. So, QU IT now. So, this IT total IT you need to use, and then we have A is the area of the UTC. So, what is the area value here? Okay, area is given, is hidden area. Okay, area is given. So, QU is MCPDD. Okay, QU is M dot Cp then dt. Okay, so dt has to obey this, and then you have IT then A, but see what is given to us is 36 cubic meter per hour. Okay, so that means this 36 cubic meter per hour meter square. So, if we multiply with density of air, okay, then what will happen, and its unit is kg per cubic meter. So, this will goes off, then what you will get kg. So, density of air is maybe you can consider 1.2. Okay. So, 36 into 1.2, then kg hour meter square. That means you can use this 36 into 1.2, and Cp of air is 1005 you can consider, or maybe 007, 1005. Okay. Then you will have IT is 641. So, this A is taken care by this expression, right? This A, right. So, this A is taken care by, because this is meter square, and this is 1005, and delta T. So, delta T is how much? Is a function of IT. Okay. So, I will just rub this part. Let's erase this part. Okay. Then delta T is how much? Can someone tell me? Is IT is 641 plus 3? How much? 22 T3 degree Celsius, right? You substitute here in delta, this delta, that 1005 into 22.23. That means if I expand this 36 into 1.2, 1005 into 22.23 divided by 64, 641. Now, tell me what is the collector efficiency now? But you got RB 1.295, right? Omega you have considered 15, right? So, what is efficiency of the collector? 40. Huh? Yeah, 3600 you have to divide, yes. It's a unit conversion, right? So, because this is in kilojoule per second, so this will be 3600. So, finally, this will be 41 point. It's quite interesting problem, right? Just we gave some input parameters. It's a solar air heater. We gave some amount of volume flow rate per square meter, and then we have actually included all the analysis. That's why I have picked this example. So now just recalling the expression, what is RB, okay, and what is RD, what is RR, and why these expressions has come into considerations. Because we know normal radiation, we know diffuse radiations, also we know what is the total radiation falling on the collector. Okay. So that expression also we know, and individual calculations also we know. So from that we can find out if there is a expression which tells about delta t that can be expressed, okay, and of course it is justified, and also we know the expression for collection efficiency. So we can characterize the collector also, okay. So all the informations are here. So it is quite interesting, and these raw values will change if we consider a place like full of ice. So reflectivity will be different, right? So this is like a radiation shape factor with respect to the ground. So when we are calculating RR, it is radiation shape factor with respect to the ground, and but RD, it is the radiation shape factor with respect to the sky. Okay. So that's how sometimes this reflected radiation plays a very important role in the overall performance of the collector system. Okay. So it's good, and also we'll solve one more problem quickly, and then maybe we'll we can little bit early you can start the exam. Okay. Fine. Okay. One more very interesting problem. Okay. Now we have to solve. I am not going to solve anything. So you can help now. So a water heating flat plate collector is fitted with two glass covers and a non-selective absorber plate. So no selective plate is there, and the dimension is given, and the collector is tested under standard procedure, and following data are generated. So you know TFI, TFO, then TA, IT, all these values are given. Okay. And also tau alpha average, then mass flow rate, then CP, and then AC to AP is given to you. We need to calculate instantaneous efficiency and plot this against the parameter TFI minus TA, and draw a base fit straight line, and determine the values of UL and FR. Okay. How does the values of FR changes if the values of mass flow rate is reduced? So mass flow rate I am going to reduce it, because see this is what flat plate collector, and we are dealing with water. In the earlier example we were dealing with air, right? So this is for water. So now we are increasing or decreasing the mass flow rate. That we would like to see what happens if we do something like that. Okay. And for assume the value of this does not change significantly because of the increase in mass flow rate. So this same FDS we can use for both the cases. So can you do it? Everyone is having a laptop, right? And also internet access. No? Then how will you write the exam? You need laptop. Mobile is also okay if you have Gmail account. Gmail? Wi-Fi access नहीं? You can do something. There is no shortcut. Things are there. No network. Why you are saying network is not there? Let me check if I get something from there. Can you do it now? What will be the efficiency? You remember this? In the class we said in testing. So, two parameters we have considered, that is not T f bar, T f 4 minus T f I divided by I t, right. So, that you consider T f o is there, T f I is there, and divided by I t you do, and then you plot it, then you see what you will get. So, you will get this kind of plot. If you have a spreadsheet, like no computer and then a spreadsheet, immediately you can plot it. So, just I have no picked the things, that is why nothing is there in the x and y axis, and of course, this will be efficiency, and this is the other parameter T f o minus T f I divided by I t. So, that means you have this efficiency values. Then once you can once you draw it, this is T f I minus T a, sorry, T f I minus T a, then I t, and then you can find out what is U L and F R. So, actually you need this laptop here, it is very easy to do it. laptop lấy này, exam नहीं देना है. लैपटॉप लेके और तो कुछ नहीं होगा, ग्रेड नहीं चाहिए. You have to go fast. इसके पास तो कंप्यूटर नहीं है. Computer you are carrying for fun, not for work. एक्सेल यहाँ पे कर सकते हैं, है ना?
एक्सेल नहीं, एक सर करके दिखा सकते हैं हम लोग.
एक कहाँ है, सब तो करना पड़ेगा.
यही है क्या एग्जाम?
एग्जाम नहीं है, एग्जाम ये तो पूरा सुपर असतं. So you can do it, right? Okay, fine. कहाँ गया? So, okay, you can generate this kind of plot and you can calculate this way. So, area is given and then efficiency you can calculate, and then for first set you can do this, and then second set you can do this. So, you can do for all these things. Okay. So, by doing hand calculations you can plot it now. So, this will give you a lot of understanding. This is a very interesting problem. So, why I am choosing this problem, because if you sense the mass flow rate, nothing will happen actually. That is what you need to demonstrate. I think there is a mistake here. If you could figure it, it should be T A, right. So, if you see this T F I minus T A by T, at least you do the first calculation. So, what is T F I minus T A? So, this is 84.95 minus T A is how much? It is 23, right. 23, then you have I T is this much, 885. What is this value? 0.07, and for this just do it once again. -79 minus 23, minus 22.4, 79.97 minus 22.4, then 879. Tell me. 65. Why so variation? Then this minus this divided by this, how much?
0.062.
This is 0.
0.065 second one.
Yeah. Then 69.54 minus 21.6. How much it is?
0.057.
Next, Akash. $68.19 minus 21.3 divided by 827.
0.056.
56. Then this and this one 43 minus 20.4, 7 divided by 792.
0.0292.
Then 38.17, and last part 33.29 minus 19, 761. What is the efficiency? Oh, again you need to do efficiency, right? This parameter is something like TFI Fi minus TA by IT. Okay. And what is the efficiency term? MCP TFO minus PFI I so what is delta T here? TFO minus TI. Can you tell me these two differences? This minus this 93.98 minus 84.95 02, right? So someone can do this calculation. So this part is done. So efficiency term you can do. So this A is how much? 2 square meter, right? 2 square meter, and then I is first case it is 885, and then M is 1.1, and this is 1.1. Then we have 60 at the bottom. Okay, and Cp of water is 4.18. That means it is in kilo, and then you have to have this one, and then delta T. Minutes, that's why 60 is here. Okay, 60 is here, 885, then 2, and you can make one, like Excel sheet, and immediately you can tell actually this part, because this will be fixed for all. Okay, only variable will be this part, and of course I will be your variable. So what is the second delta T? Then third one? Then other people are sleeping or what? Only one guy is months. Bidu 61, 77.36 minus 68, 9.17, 11.14, do it quickly. This is also 11 point something.
What one is missing? 11.62 is for 38.16.
Oh, then here.
10.6.
Okay. So now you calculate this. So, can someone tell me what is this value 1.1 4.18 into 10 raised to the power 3 and then a divided by a, and this part will be variable, right. So, if you multiply, that means 1.1 then 4.18 okay, then you will have 60 into 2. So, this part will be fixed and delta TFI will vary. So, this TFO minus TFI by I, this will be the variable. Okay. So, what is this value? 60 is for this minute. So, 1.1 divided by 60. This part? No, I will be varying. I will be varying for every cases. Okay. So, this part is fixed. So, what is the value of this part? This part, right? 38.31. 38.32, and then for every time this will vary. So, this is known divided by IT. So, that is why I said no, if you have computed any very quickly you could have done it here. This 0.3.
Efficiency is 0.3.
0.3
Total efficiency
is
0.3, so 38%.
30
39.16.
for this case, first case
First case.
39%. So, that means you can plot it.
Sorry.
Oh no, oh, very good. Someone can come from top, then you can convert somewhere. Okay, very nice. Yeah, very nice. So, that is plot is also there. Then we can find out these values. Then we can find out these values UL and UR. So, that by using this curve fitting, we can find out what is mx plus c.
So now efficiency is calculated.
Efficiency, and then this other part like TFI minus TA.
Yeah, which is there.
Yeah, these two. So, this will be in the x axis and this is the y axis.
This one is
Yeah, this will fine. Yeah, this will be fine. So, fitting coefficient again. I think you right click it, I will get it there.
There it's also.
Yeah, I click.
Here it's okay.
Formula. Okay, should come.
Yeah, actually
Equations it will come.
should come. See, I have to select everything together.
Equations.
Now
Yeah.
it is coming, but here plus error bars.
No, third line, third line.
And after that here
Linear.
and more options we click and
Linear equations. So equations,
so equation will be there.
display equations also are score values.
So
Yeah.
let's make it big.
Yeah. So now can you tell me the expression? So this eta I is equal to 0.6. minus 0.6 minus something will come. No, y is equal to mx plus c. That equation what we have discussed.
Minus 3.5412x minus 3.5412x
541
2x
2.
2x.
That x is something like tfi minus ta by I, right?
Yeah.
And this is 0.6.
0.6466.
Okay. So what is this value now? And what is this value now? You remember?
Slope intercept.
And this is intercept and then slope. So intercept was something like fr AC by AP tau alpha average. And this is equal to 0.6466, right? And then what is this value? Other values? So tau alpha is known, and then this is UL. This is what UL AC by AP is 3.5. Okay. So now you can find out what are the values. It is quite interesting problem. So you know already AC by AP is 1.2 and tau alpha average is given to you. Okay. Now we can find out what is UL and what is FR. Okay. So now it's very easy, everything is known to you. So your FR and UL can be found out, right? Now next question is, if we change the mass flow rate to 1.3 kg per minute, then what will happen to the value of FR? So you can see, then you can tell me what happens. Then again you need to do this entire calculation. If you have computer, immediately you can do it. So in hand calculation it will be difficult. Just you change this parameter mass flow rate. So from 1.1 to 1.3, and once we could develop this expression y is equal to mx plus c, or here y is equal to minus mx plus c. Okay. So that if you can develop, then immediately we can find out what changes you will get, FR value. Not much change will be here. So what FR you got now?
FR is 0.97281.
Yeah, 0.7281. So FR is 0.7281.
So you want to change the
Mass flow rate
1.1
1.3.
1.3.
Yeah.
We have a new equation.
Yeah.
New equation is FR, right? So 0.7641.
Yeah. I'll just write there. So our new equation will be 0.7641 and 85. Okay. So now, if you could find out this FR, then what will happen? Because this is nothing but FR multiplied by AC by AP. Then you have tau alpha average. So here I want FR and how much
previous effort 0.7281, current effort 0.86.
but there is a significant change. You need to check somewhere. You made mistake, I think. There should not be so much of difference. Yeah, so very close. So that's how we can say that even though there is a change in mass flow rate, there should not be much variation of these values. Okay. So it's an interesting problem. So this actually leads to one kind of design of flat plate collector. Okay. And you can extend this understanding for other collectors as well, where liquid is injected into the collector system. Okay. So, we can finish it there. All right. Okay, please exercise this kind of problem, and it's fine. We can go on doing the exercise, but no, if you were concentrating in one exercise very precisely, I think other things also you can do it. So we have solved for drying, we have solved for solar air heater, and then we have solved for liquid flat plate collectors. So all the things we have touched, and we have given thoughts about it. So we can conclude here this session, okay, and maybe for some time we can give a break. Okay. Then you can come little early. You can start. I think since all people are here, online, but we can explain. We can tell them right now. We can start little early. 4 o'clock will be good actually. Then we can do something at the end. Okay. Okay, then we'll break for half an hour, and then we'll start at 4:15. Please ready with your system, and it will be online test. Okay, and everything will be there in our system after exam is over. Then we could able to give the grades. Maybe for getting grade from academic section, it will take some time. But we'll complete our process today itself, and because his signature is also required there. Okay. So thank you very much for your presence, and maybe one more photograph we can take.